Hello, organizers and participants. My name is Paula. I'm a PhD student at UFRJ, supervised by Professor Ribamar, and I'll present here my poster entitled Estimating a BU in Real Space. In this study, we used data from the Slow Digital Sky server, BOSS survey data release 12, to obtain the BAO from the power spectrum, which is in real space. And the data, which are basically low Z mass sample, is made out of galaxies, over 990,000 galaxies, from redshift 0.3 to 65. We also used 500 mocks to compute the covariance matrix and fit our data to a model. And the estimated power spectrum and also the model was computed using the AnybodyKit open source code, which is available for large-scale studies. So our main objective is to obtain the BAO feature, and the best way to do so is using this quantity dilation scale, which is a geometric mean of the angular diameter distance and line of sight distance that represents the feature as a single quantity. Before getting to this final result, we need to first fit our estimated power spectrum from the data to a model. And there are several steps to do so. The first one is to compute a smooth model, in which we have this part without the BAO multiplied by the bias parameter, and the polynomial part, which is used to correct small-scale issues. The next step is to obtain the fitted power spectrum, finally, which applying the smooth scale by this other part, the oscillatory part of the function. We have this parameter, which is the most important one, the alpha parameter. And from that parameter, we'll get the final, the dilation scale. Also interesting to visualize the BAO through a Vigo plot, which is simply dividing the fitted power spectrum by the no BAO part. This isn't a new fit, simply visualization. So here in our results, we have the power spectrum and logarithmic plot. The estimated from the data are the points. Blue is the southern galactic cap, and green the northern galactic cap. And in black we have the model refitted. And the blue region is the 1 sigma posterior spread of that model. And it's here in the wave number, we see that there are Vigos, which is the BAO, in around 0.04. And this is more larger errors, both for the model and the data, is due to the cosmic variances. It's on larger scales. It's easier to see the oscillations from 0.04, like I mentioned, using the Vigo's plot. And we see here, because the northern galactic cap is larger than the other cap, you can see that it's better fitted to the model. Here we have the most important parameter, which is alpha. And that result, we use it to compute the dilation scale for the redshift, for the effective redshift of our sample, which is 0.5. And we found the quantity of 1,792 megaparsecs. We can go further than that and compute the relative BAO distance, which is the we compute dividing the sound horizon at radio clock by the dilation scale. and we found the result of 0.08. So in the study, we obtained the BO using Anybody Kit. It's an open source code. And we found that the BO starts around 0.048 per megaparsecs. And we intend to compare these results to other publications. Lastly, here are the references used in the poster, and thank you.